kind of at the endish. Okay, so if you're just listening to this recording, the way I have to do this is I forgot to start the recording, so now I did. You'll listen to this part, and then I'll go back to the beginning later on and add to that or make a separate one, whatever. Okay, so this is the ellipse, and for it to be an ellipse, it has to have a plus sign in between the x squared and the y squared, and otherwise it would be a hyperbola. It is going to be centered at the origin, and it is always equal to 1. So the number that is under x squared is a squared. So if there was a 15 under there, then a would be the square root of 15. If there's a 25 under there, a would be the square root of 25, which is 5. So the number that's under x squared tells us what direction we go, left or right, and we go a in both the left and right direction from the origin. And then the b squared, whatever b is, we go b up or down. So those are the kind of the things to note. And you have all this on the handout, and it kind of explains that. So here's a little picture of one. So this one would have started out as x squared over 25 plus y squared over 4 equals 1. So we have to say that a is 5, b is 2. And so from the origin, we go 5 that direction and 5 that direction, 2 up, 2 down, and then we just kind of try not to make them pointy, as the author of this slide says, and then kind of see what happens. So I'll just sketch freehand this one because I didn't put any graph paper in these. So this one is already set up for us. I'll just make a little axis, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. And then for this one, A is 1, so we go 1 to the right and 1 to the left. B is 3, so we go 3 up and 3 down. And then we just put our oval-y shape in there, and we're good to go. So that's an ellipse, and that's as difficult of an ellipse as you have to know about. Does that make sense? So then the next one is the hyperbola. And so then the big difference, this is the formula you want to know for a hyperbola. The big difference is that this is a subtraction. And so when it's a subtraction, you get kind of those two parabolic parts that are kind of opposed to each other. And here's the deal. And there we go. Here's the deal. If it's x squared first and then minus, the picture looks like that, where they go kind of sideways, like this and like that. But if y squared is first, and it's the subtraction problem, so here the y squared is first, then it's going to go up and down. So also think about the fact that x is horizontal on the horizontal axis. So that should make, kind of a little sense that it would be sideways. And y is on the vertical axis. So it's going to go up and down. So something so that you can kind of know that's what's going to happen as we look at that. So that's the deal. So you might be thinking, oh, an ellipse is pretty easy to graph because you just go, A left and right, B up and down, and you're done. That a hyperbola, boy, how am I going to figure that out? But actually, we use the ellipse to draw the hyperbola. And so there's a lot of like non-hyperbolas there. And oh yes, there's another little joke or something. I don't even know what it is. But here's how to graph a hyperbola. And we start with an ellipse, thinking of it in terms of an ellipse. And if this had been with a plus sign there, that would be the picture of the ellipse. And so that's the ellipse that we're going off of. But in this case, it is not a plus sign, so I'll get rid of that. And so we don't draw the ellipse, but we plot those 4 points for the x's and the y's, just like we would, and you can see them down here. So A is 3 and B is 2. So we go 3 this way and 3 that way, 2 that way and 2 that way. Then, and I'm actually going to finish this one on here, but you can look at the slides on your next picture. And I'm going to use a yellow marker, I think. Let me just kind of slide that all the way. So what you do is you draw this a rectangular box, and you're going to use grid paper probably, so it won't be that hard. You draw a rectangular box, and that's kind of, you know, inside of that hyperbola. That's going to, you know, that box is someplace in there. And then it has asymptotes, and the asymptotes go through the corner of the box and the origin. So one asymptote is going to go kind of like that. I kind of missed the exactly corner of the box and the origin. And then corner of the box, origin, corner of the box, and it looks kind of like that. Then, since this one, I'll go back up to it a second. Since this one had x squared first, I'll put x squared first. Then it's going to go like that. And then all we do is, this is a vertex at the right side of the box, that point that was on the ellipse, and then we just draw in that parabola, and it actually goes closer and closer, doesn't bend back in, and it goes forever in either direction. So this one close there and then close there, and then we have the hyperbola, and so it's just very related to the ellipse. So the next slide, I'll just kind of go through it now. Here's the box, there's the asymptotes, and then there's the picture. And we've talked about asymptotes. So it's really not that bad in terms of the problems that we'll do. Ours will all be centered at the origin, so that's not going to be kind of a problem for us as we go. So then on the next slide, oh, these are a little more like art projects. So they just did another one that's going to go the other way. So here, y squared is first, so that means it's going to be that kind of hyperbola as we look at it. A is, oh, excuse me, A is in the back now. So A is 4, so that's something to be careful of. It still is left and right based on the x. B is equal to 1, so it goes 4 to the left and to the right, 1 up and down. We draw the box, draw the asymptotes through the corners of the box and the origin, and then since it's y squared first, when we draw the hyperbola, oops, there we go, then it just goes up, and this one is really flat and wide, I guess, as we look at it. So then now it's our turn to draw a couple of these, and we'll put this one over there and we'll put this one down there. So this is a hyperbola. These are both hyperbolas. Hyperbolas. And so this one has x squared first, and so it's visually going to look like that. This one has y squared first, and so it's visually going to look like that. And I usually, in my head, identify that right away, so then I know kind of what's happening here. And so on this one, a squared is 4, so a is 2. B squared is also 4, so bless you, B is 2. Someone just sneezed. So this one is square. That's good and bad. It's easy, but it doesn't make us distinguish things. It's this one that is going left or right, and so I'll go left and right too. and then it's this one that is going up or down, up or down, up and down, excuse me, and 2 and 2. And then I'll maybe just use a little broken line even to draw my box. And if I'm on grid paper, it's pretty easy to draw those boxes and things. And then much more difficult for me personally to draw the asymptotes in there. Oh, not for this one though, because it goes right from corner to corner. So then my asymptotes go through the corner of the box, and in this case, it goes through, you know, the line y equals x and y equals negative x, but that won't always be the case. And then I already had established that this one will go to the left and the right, and so then I just sketch it in. I'll write my answer in red. And so from here, it goes like that, and like that. From here, it goes like that, and like that. And like I told you, you're not going to have to do the more difficult hyperbola problems. They'll be pretty straightforward, so that's the good news. We won't go over the more difficult ones, but as you can imagine, it could be centered someplace other than the origin, right? That should just make sense as what the other option would be. So then here, always I have to be careful because in this one, a is still with the x squared, so a squared is 9, so a is 3. B squared is 1, so B is 1. So I go 3 to the right, 3 to the left, 1 up, 1 down. I draw in my box, and I only am using a dashed line just so that, oops, it's easier for me to tell. Then that's a little harder for me to draw my asymptote in, and so really I had to count out at the end, I think. I think my asymptote can go there. And there. I may not have quite gotten right where I wanted to be. And so then my answer for this one, I had already established that it was going to be an up and down hyperbola. So I go from there. Ooh, and it's also quite flat looking. And that is the hyperbola for that one. Then I went to some problems. I'll just leave these for you. Identify the center and radius of each and then sketch the graph. So for this first one, the center is 1, -3. The radius is 2. Just to kind of remind you for things. I just put this one on here as well since we didn't have a definitive lesson about it. For the circle, just a reminder that you should know that. For the ellipse, no, that was a circle. For the ellipse, this version, you can see the more difficult version. We just aren't going to have to know that right now. It just gives a different center. The hyperbola, you'll want to know this as you go. And I think that's everything there. Then I put a couple of, there's an ellipse right there, and this was just whatever I could kind of find. I have a hyperbola there and a hyperbola there. And then I have some graphing equations of, parabolas. So I will just comment on this. These are parabolas, and we just want to remember, because this is my review of graphing. So the new things were on here, but I'm also going over old things. So y equals a times x minus h in parentheses squared plus k. I think I had a extra slide on mine. Yes. And actually, I'm going to start over here. So for a parabola, because I'm going to write a little bit more. Y equals a times x minus h squared plus k. This is vertex form. And you know how to get it in vertex form by completing the square, just as a reminder to you. Just little things also as a review. If a is positive, it's a parabola like that. If a is negative, it's a parabola like that. The absolute value of a, if it's greater than 1, it stretches it vertically. Vertical stretch, which means it makes it narrower than the original. And if the absolute value of a is between 1 and 0, then it's a vertical shrink, and it makes it, more boldly kind of out as we go. The vertex is HK. So do be careful because for H it says subtracted problem. And I think that's everything about a parabola. I didn't write anything down about a trig function, and but I maybe should write some things because there are some graphing questions about trig functions, and I didn't put anything in the review because I couldn't find what I was looking for. But I'll maybe just comment on some things. So a trig function, and I didn't write anything down. Trig function, y equals a sine bx plus c plus d. So the absolute value of a is the amplitude. If a is positive, it's just a regular sine curve. If a is negative, it's reflected in the x-axis. If it's sine or cosine, the period is 2 pi over b for sine or cosine, and for tangent, it's pi over b for tangent, and it's co-functions. We'll just kind of say it that way. Phase shift. And actually, those are probably the absolute value of b because we don't use usually b is positive, but we don't kind of consider it that way. Say that again? No. And then phase shift is negative c over the absolute value of b. And that tells kind of the left or rightness. And d is translated up or down. Translated up or down as we go. So I know I took a lot of your time today, but I do think I not only went over like the conic sections, but the other things. I think I will give you your tests. You know what? I think what I'm going to do then, since I don't have the tests sorted, and if you just are honorable to me, I will allow you to check out your tests. Would you like to do that? I'll let you check them out from Monday to Tuesday for sure, okay? Can we do it that way? Because we don't have class tomorrow. So you can check out your tests from Monday to Tuesday, and then those handouts should go in the gray tray, just so that you're aware of that. And then actually I'm going to back up to the people who were missing. So if you were gone today, I have that stapled packet of determining your grade with all the quarter grades in it. So yes, so it has to be stapled. If you didn't staple it or I didn't staple it, you can put the stapler there. And so if you are gone today, then I gave the quarter grade sheets. You can just stop in and talk to me about that if you want to drop a grade. And otherwise, I'll give that to you on Monday. If you are gone today, there's this site. And what we did at this site is we looked at, and I'll just, oh, why? Yeah, I am. Yeah, it's right there. Yep, I'm recording 20 minutes. So if you go to this website and you were gone today, there are these 1, 2, 3, 4, 5, 6, 7. We watched, because it's a little dynamic, there's a little animation. We watched 1, 2, 3, and 4. And then 5 through 7 are on the handout packets that you should have gotten from Nick Shimmick. So I'll just kind of tell you that. And then we just went through that, and then we skipped to this page with circles on it. And we had started talking about circles, which you're familiar with already, centered at the origin, and then also the fact that you have to know these versions of it where the center can be not at the origin. We did a poor job of graphing one of those. And then I think when I started talking about ellipses, I was back there. So my apologies for not starting that right away.